Here we have an energy transfer question. So the diagram shows a heater with two switches. One switch is for low power, one switch is for medium power. When both switches are on, it's now high power. What is the power for high power? So you've got 0.5 for low, 1.5 for medium, so we just add them together to get 2.0, and we need to write that down here. Okay, for this question, the heater is used on high power, so we've got to use our 2 kilowatts. It's on for an hour and a half. Now there's two different ways to work out this question, and it's a 3-mark question, so the units are going to be very important. That just splits up. The quickest way to do this is if we want to use our units of kilowatt hours. So we have 2 kilowatts. We times that by our 1.5 hours. That just gives us 3 kilowatt hours. Nice, easy to get 3 marks. Some of you may not have covered that and are using the Joule method, in which case we need to do conversions. So 2 kilowatts is 2000 watts. 1.5 hours is 90 minutes, which is 5,400 seconds. Then we times them together, so you've got 2,000 times 5,400, which gives 108,000,000, or in standard form, 1.08 times 10 to the 7 joules. So either 3 kilowatt hours or 1.8 times 10 to 7 joules. But you need to make sure you show all your working for questions like this, and always the units if they're not given. It's always worth a mark. This type of heater is very efficient. What is meant by being very efficient? There's a few ways we can answer this. So we could say it does not waste much energy, or most of the energy is useful. So either one is those is fine to get that mark. So here we have a graph, so we need to make sure we look at the axes as well, not just the pattern. The graph shows how the temperature of a room changes during the 1.5 hour the heater is on. So during that first half hour we've got an increase in temperature, then it starts to level off. So the heater is still on at this point. After 1 hour it becomes constant, even though the heater is still switched on. So even though it looks like it's levelling off, and it is, the heating is still switched on. So that means the room is losing energy. And the fact that it's saying a straight line means it's losing energy at the same rate that the heater supplies it. So you can think of the little room. The heater is giving out 100 joules of heat, for example, and the room is losing that 100 joules of heat. So you've got 100 going in, 100 going out, so overall there's no change in energy. That's why the temperature remains constant.